Our next big of our big three, product rule, quotient rule, chain rule. We've talked about product rule, we've talked about quotient rule. Next up is the chain rule. These are the big three. Now we've talked about how to find the derivative of two functions that are added. That's very straightforward. The derivative of the sum is the sum of the derivatives. We've talked about how the derivative of subtracting functions, the derivative of the difference is simply the difference of the derivatives. We've talked about how to do the product. This is the product rule. Right? We have to use the product rule here. Here we have to use the quotient rule when you're dividing. But if you recall from your glory days in algebra, there was something else called composition. What if you have a function of a function? This is actually that, as students always call it, that Fogg and Goff stuff. It's the composition. So the question is, how do we do the derivative of this composition? And to do that, that's what we use, for which we use the chain rule. The chain rule is used to find the derivative if the argument is not simply x, if the argument is another function. And so this might come about something like this. Suppose our function is this. If I have sine of not just x by itself, I have sine of some stuff. And I'm going to do it conceptually this way. This can be any expression. So an example might be, suppose I have sine of 3x. Or if I have sine of x squared plus 4. Or if I have sine of cosine of x. This could be, what is inside these parentheses could be any expression. All right? And so I'm going to just take all, and there's nothing magic about sine. This would be the same for tangent or cosine or secant or any other function we have here. Right? Any function we have here. If I have a function of a function, this is some other function. I'm going to do this conceptually like Mr. Collins used to do when he taught this. This is just some stuff. I think the word he tended to use was blob. I'm going to do it much more sophisticated than that. I'm going to use the word stuff instead of the word blob. But the notion is the same. The derivative of f of sine of some stuff. This is the chain rule in action. I'll just illustrate. And then after we get used to using it, then if we like, we can go through and talk about a proof of why this works the way it does. But in terms of just how this works, the derivative is this. The derivative of sine of some stuff is cosine of the stuff. And remember, whether you're using product rule, quotient rule, or chain rule, somewhere in that process you need to copy, paste. If you don't copy and paste, you made a mistake somewhere. Well, here it is. The derivative of sine is cosine, which is, derivative of sine is cosine, but then this is copy, paste. Copy, paste. This does not change. The derivative of sine of something is cosine of the something. But the chain rule says you need to multiply by, and I'm going to do this conceptually, derivative of the stuff. You multiply by the derivative of whatever is inside these parentheses. So let's do a specific case. Suppose f of x is something very simple. I have sine of x squared plus 2x. All right? This is sine of some stuff. The chain rule, when we do the derivatives for the chain rule, you work from the outside in. You work from the outside in, not the inside out. Work from the outside in. The chain rule works from the outside in. And so you do the derivative of the outside function first, the inside function second. And if you have parentheses within parentheses within parentheses, you have function of a function of a function, you work from the outside in, the outside in. All right? So the derivative of sine of this, now the role of stuff is being played by x squared plus 2x. So the derivative, do you see it? The derivative is, the derivative from the outside in, derivative of sine is cosine, copy, paste. You only do one derivative at a time. Derivative from the outside in, sine is cosine, copy, paste. If you don't copy, paste, it's wrong. This is x to the second plus 2x. There's my copy, paste. But then it's always time. Now, you've done the derivative of the outside piece. Now we need the inside piece. So it's multiply by the derivative of what was inside here. And the derivative of what was inside here, in parentheses, is 2x plus 2. And that's finished. If all you're asked to do is find the derivative, then you do not need to simplify. You don't need to try to clean this up. Just let it sit there. All right? Let's make that neater again. Let's say this is derivative of x. Derivative of sine is cosine of the stuff times the derivative of the stuff. And we're out. You work from the outside in. But if you do the outside piece, then this is copy, paste. And then you take the derivative of this as if this is the only thing written up here on the board, times the derivative of the inside. And so the way the name comes from is we just link this on. This is multiply here. All right? So we can now, what's left here is to practice this several times. All right? So let's continue to play with the trigonometric functions a little bit. Let's see if we can do something like this. Well, suppose I take f of x is, let's do tangent of, and let's say tangent of cosine. So this is a function of a function. Anytime you have a function of a function. Now listen to me. I've had students in Calc 3. I have had students in Calc 3 mess this up, and I just wanted to do something I shouldn't do. This does not mean tan times cosine of x. This does not mean multiply. This does not mean multiply. Oh my gosh, I have students do this, and it just drives me batty. What they try to do is they try to do a product rule, and they say first times derivative of the second. That's not a function, that's a color. That's not a function. This doesn't mean tan times cosine. That would be this. Yes, this does mean tangent of x times cosine of x. This is the product rule. This is the chain rule, because this is a function of a function. You must see the difference. If you don't see that difference, you need to make sure and concentrate to see that this does not mean tan times cosine. This is tangent of cosine. This is the chain rule. And we work from the outside in. So the derivative here is derivative of tangent of something is secant squared of the something, or tangent of stuff is secant squared of stuff. So this is secant squared. You're working from the outside in. Secant squared of copy, paste, copy, paste, copy, paste. Boom. So this is cosine of x. Tangent of cosine of x, working from the outside in, secant squared of cosine of x. But then, chain rule says, times the derivative of the stuff. And what is the derivative of the stuff? What's the derivative of cosine? The derivative of cosine is not sine. The derivative of cosine is negative sine. And now you're seeing why I put these parentheses here. Every stinking time. Like, this is the one true faith. I put these parentheses, and you should too, every time. Because if you do not put those parentheses, then you will write this. You'll write secant squared, derivative of tangent, secant squared, copy, paste, derivative of the inside, you'll do this. That is wrong. This says secant squared of cosine minus sine. This isn't supposed to be minus, it's supposed to be multiplied. So always put, whatever the derivative of the inside is, always put it in parentheses. If you don't need them, it won't matter. If you do need them, it makes all the difference in the world. So, chain rule, chain rule, chain rule. Work from the outside in. The derivative of tangent is secant squared, copy, paste. Then whatever you copied and pasted, then you see that's the only thing on the board. That's the only thing present. No, nothing else is here. What's the derivative of cosine? It's negative sine. Make sure that's multiply and you're out. The only thing left to do is go through several examples, and that's what I'll do on the next video. I'm going to go through several examples of many different kinds of chain rules and how they work, working the chain rule with the product rule and the quotient rule with the chain rule and how that all works out. And then second derivative with the chain rule. All this stuff works together. So I'll work several examples of chain rule next, but that's the basic structure. A couple principles. Anytime you have a function of a function. This is not the only kind. I've only talked about trigonometry, but in the next video I'll do some that are not trigonometry. Anytime you have a function of a function. Anytime you have a function occupying where ordinarily you would just see a single variable x. If you have a function of a function, you work from the outside in, and you must copy, paste, whatever you pasted, take the derivative of that. All right, and that's got to be multiply, and those are the principles for working with the chain rule. So we'll go through later, next we'll go through several examples, and then we can talk about a little proof of it if you like.